All right, so for this lesson, we do a little review of probability. So something you probably haven't done since stats, but it is an Algebra 2 topic, and it does show up on your ACT. Obviously, we're not going to be able to cover everything in probability, but kind of some basic, questions that you should be able to figure out on a test. So we'll start with kind of and or probability. So let's start with the just first example here. There's a spinner with 20 equal areas, numbered 1 to 20. If the spinner is spun one time, what is the probability that a result is a multiple of 4 or 5? So what you got to do is, first of all, come up with the numbers 1 through 20 that are multiples of 4 or 5. So obviously your multiples of 4, you got 4, 8, 12, 16. And then multiples of 5 being 5, 10, 15, 20. 20 is actually a multiple of both of them, but you don't count 20 two times, okay? So there's a total of 1, 2, 3, 4, 5, 6, 7, 8 that are a multiple of either 4 or 5, or both. And there's a total of 20 spots. So basically it's just 8 out of 20, which if you reduce that gets you 2 out of 5. This next one can be a little more complicated, and I'll show you kind of how to organize how to do it. So in an Algebra 2 class of 24 students, 14 play basketball, 8 play baseball, 6 play neither. What's the probability that a student chosen at random plays both? So, obviously we're dealing with, a situation out of 24, but it's kind of hard to figure out, okay, out of the ones that play basketball and baseball, which ones are playing both? So what you want to do is make yourself a chart. And I suppose my lines are going to be kind of crooked, but that's okay. So we got kind of two variables going on here. I suppose let me finish making my chart here. At least go this way. Hopefully I didn't make too many spots. I don't think I did. And you're probably thinking, why do you need all these spaces? Well, I need a title. Okay, so let's start with basketball. So we'll put play basketball. So they can play basketball or they don't play basketball. Okay, and then we'll have a total here. And then we'll have baseball. And then those that don't play baseball. Those are the two options. And then we got total here as well. So look at what we know. Well, the total of all the students is 24. So that's what we put there. We have 6 that play neither. So no basketball and no baseball. So that needs to be 6. So we got 6 there. And then we look at, okay, how many play baseball or play baseball? The total of people that play baseball here is, lost my spot, 6. Or no, not 6. 8 play baseball. And then for basketball, we have a total of 14 that play basketball. So total for basketball would be 14 there. Okay. Now, we have a total of 24 kids. So if you add up our two totals, we have to get a total of 24. So there has to be a total of 16 there that don't play baseball. If we look up here, our total for don't play baseball is 16. So we would need 10 there that don't play baseball. And we're looking for this both number here. And here we'd also have a 10 to get to our total of 24. To get to a total of 10 down here, we would need 4. And to get to a total of 14 down here, we would need 4 that play both. So 4 play both. So then we would take 4 out of our 24 kids, which reduces to 1 out of 6 chosen at randomly would play both. So make a chart, with your variables and your totals, and then start with what you know and then fill in the rest to figure out this number, and then you put it over the total. Next examples here are called compound probability, so probability of more than kind of one thing happening. So what we have here is a bag contains 3 red, 4 green, 6 blue marbles. What's the probability to the nearest thousandth of drawing a red marble and a blue marble? So let's start with red. Okay, now we have a total of 13 marbles here, 3 plus 4 plus 6. So to draw red, it would be 3 out of 13. Okay, now if we want to, then we're going to draw a blue marble. Well, to draw a blue marble, there are 6 blue marbles. But now there's not 13. There would be 12 marbles left because you already took 1 out of the 13 away. So then if you multiply everything, multiply across, you're going to get 18 over, let's see, 144, and then another 12 would be 156. Says to the nearest thousandth. So we would go to our calculator and divide. 18 divided by 156. Okay. And so thousandths, we have tenths, hundredths, thousandths. So 3 decimal places, so the probability would be 0.115. Okay, and then the next one, we got 5 reds, 5 blues, 4 green marbles, because apparently I needed another n. What's the probability to the nearest 0.1% of drawing, excuse me, 3 red marbles? So, probability of getting a red is 5 out of a total of 14 on the first draw. So 5 out of 14. Okay, and then we got to find the probability of drawing the second one. Well, now there's only 4 red marbles left out of, now there's 13 total marbles. And then the next one, well, now there's 3 red marbles left out of a total of 12 red marbles. So we got to multiply all these numbers together. So 5 times 4 times 3 would be 60. And then over, let's see, 12 times 13 is 156 times 14. So 156 times 14. So 2184. And so now to get our percent, we divide. Okay, and so as a decimal, we get 0.0274725 and so on. So from our percent, we would move that decimal place over twice. So it's about 2, and then I think it's a tenth of a percent, so that would just be 1 decimal. So we'd have 2.7% here. Would be the probability. Again, it's not all the probability questions you'll see, but it kind of gives you an idea of how probability works. So, got to get 6 questions right on this assignment total. Although you do lose one if you get one wrong, you kind of know the deal. So, another Delta Math. I'm going to do ACT Practice 3 is what it'll say on there. So, there's your probability lesson, and go get at that assignment.